Thank you, Anna, for the nice introduction. Good morning and welcome from Vienna. My name is Tobias Zillner. I'm lead IT security consultant at AlphaStrike Labs. So we are a company focused on industrial security, offensive security, and security by design. And today I want to share some of my experience I gathered in a lot of security assessments I performed, and try to show you and give you some insights how modern attackers work and how they try to get your passwords and your data. A little bit about our company. So as mentioned before, we are focused on industrial security. So usually we do security testing for bigger infrastructures or critical infrastructures. We also test systems like trains, planes, or ships. So not only the traditional IT systems, but we only do red teaming engagement, social engineerings, and we're also very proud of our open source intelligence services. From a defense perspective, we are also helping clients build secure products. We are helping them getting security by design into their products. Yeah, this is from my side, and I want to hand over to Michael for his introduction.
Thanks, Tobias. Hello from Wiesbaden, Germany. My name is Michael Veit. I'm technology evangelist at Sophos, and I've been in IT security for more than 22 years now, and I specialize on defensive security, like designing security infrastructures, also testing security infrastructures. I've also been a speaker at many security conferences and trade shows. And I'm working for Sophos, and Sophos, we are the largest IT security vendor in Europe, only for corporate security solutions, and there we provide the full set of solutions in the network sector like firewall, web, email security, and on the endpoint, which means workstation security, mobile security, server security, encryption, and everything. And we put all those solutions into an easily to manage security framework to get better protection and easier protection for the enterprise. But that's it so far from our side. Now let's go back to Tobias and let us see how attacks today, how modern attacks are working.
Okay, thank you. So let's start. We want to start with the first demonstration of spearfishing. Spearfishing is a very, very common attack vector nowadays. And since also the cloud is one of the biggest trends at the moment in the industry, we want to try to target our spearfishing on Amazon Web Services customers. So what we're trying to do is we try to lure employees into downloading known and trusted apps from Amazon Web Services. But in reality, we as an attacker, we infected already the Amazon Web Services command line interface, and they are not using the real ones anymore. They are using our versions with backdoors in them. So let's start. Maybe I just give you a short insight of our setup today. On the right side, you see the attacker's perspective. So we prepared a virtual machine with some attacker tools. And on the left side, you will always see the victim's perspective, so the fished person. To start off, we need to enumerate our victims. This is a very, very important step into the attacking process, because spearfishing is always targeted and not like traditional ransomware campaigns sent to a lot of people. So at first, you need a very, very secure password on your attacker server. And you're ready to go. To enumerate Amazon Web Services users, we created a script of our own. We call it AWS Account Check. So basically what this service is doing, it is trying to register a new user at the Amazon Web Services. And depending on the feedback, you know, this service or this email address is already registered or not. We started off and you will see the results. Okay, Tobias at Zillner.tech is registered already. The other address is not registered. Based on this information, it is very, very easy for us to send phishing emails to employees. So, okay, let's start with our first malware to create. and we are ready to go. So we will use a very, very popular tool called Metasploit. What we are doing on Metasploit is we configure our payload to deploy. We set it to our command and control server. We already put in some values like the port and the host to connecting to, and we just then tell Metasploit to create a malicious executable, and we call it shell. So okay, we have some technical problems here, but this doesn't matter because we already prepared the setup and already sent the email addresses or the emails out. So when you look at the victim's perspective, you will get a traditional phishing email from a, seems like, a reasonable source address called Amazon Web Services with the message, "Dear Amazon Web Services customer, please reinstall your command line interface tools." And yeah, we just go for it because we think our command line interface tools are very, very important for us. And yeah, seems like a HTTPS secure website, seems reasonable, and we download our installer, which we prepared in the last step. Very, very important also from the attacker's perspective is to set up the command and control part. So we are running on our service a listener that is waiting for incoming connections from the victims. Okay, let's start it again. Download. Yeah, seems that this easy way is not the way to go because it will be detected by a lot of the modern antivirus scanners. So we need to put in a little more effort, which means we only not create a standard executable. We now create our shell code as itself, like we create a shell.bin file, and we use a more advanced tool called shellter to backdoor known executable files. So we use shellter, which is a very, very popular tool in this industry, and we just fire it up and say, okay, as a target, we use our AWS command line interface and fire up shellter. What shellter will do is it will backdoor the AWS exe, and we then, to hide our malicious file, we also try to repack the installer. For this, we use the tool instead. We open the common installer file, and then repack the stuff. Okay. To successfully work, we just recreate or we revert our snapshot to get a real clean base now again, and we start off from before. So we now have our more advanced version. Okay. Seems like my PC is a little bit busy. Waiting for the new version of the virtual machine. Okay, just it is a MacBook Pro with the most powerful setup out there on the market, but it seems that Apple, has still some room for improvement. Okay, the snapshot is getting restored, so we're starting from the beginning again. And on the right, we are waiting for our tool to complete. We use this kind of tool sets very often in the wild and very, very successfully. So usually when we do kind of a social engineering engagement, we have a success rate from 25% up to 50%, depending on the phishing scenario we use usually. Yeah? which I think 50% is a really, really good result. So again, just start Outlook to get our phishing emails. On the right side, you see now our tools are ready. Greetings from the Amazon Web Services team. We visit, we download the installer. And this side we prepared the attacker side to get it more clean. And fire up our handler, which is waiting for incoming connections. So since now we created an installer, we now don't just only execute the don't just use the executable. We also need to install it. Yep, we install it. So you see the first difference is this isn't detected again, and just fire it up. Still getting installed. And finish. And to try to execute it, as mentioned before, this is our command line interface. We use AWS, and we see now we have an incoming session on the user's PC. Okay, this is by a default protection, but now how about Sophos Intercept X protected client?
Yeah. Thanks, Tobias. Now, first of all, let's have a look what protection layers there are on today's endpoint. So the first protection layer on today's endpoint is preventing malware from getting onto the system at all. In Sophos Labs, we see about 400,000 new threats every day, new viruses, ransomware, which has not been seen before. And 50% of those you can actually prevent by just not letting them onto your system at all in the first place. And mechanisms are web control, device control, application control, for example. As soon as the malware has gotten onto the workstation, on the Windows or Mac system, there the pre-execution things are running. That's like the traditional antivirus signatures, heuristics, script analysis, and most modern technology is deep learning or machine learning in this place, which tries to identify new pieces of executable malware by analyzing if there are any similarities to malware seen in the past. But these protection layers are not enough. So actually you need to have some layers and mechanisms which are in place during execution of a program to see if a Word macro or an Excel macro is doing something malicious, if there's password theft in memory, or if exploits are used to infect systems which are not fully patched. So these are additional layers of protection to get the most modern threats. When threats have been detected, there are of course many ways of reacting, like blocking, quarantine, synchronized security, which is Sophos' way of telling other systems that this client is not secure anymore, like telling the firewall that this system is infected and don't let it into the internet or to the servers anymore, or even more advanced things like a central reporting or a root cause analysis. I will come to those things later. Just to give you an idea, the next generation endpoint, Sophos Intercept X, is not replacing the traditional antivirus. So the traditional antivirus, which you have in place, hopefully, is what's grayed out here. Yeah? So there's the device control, application control, AV signatures. That's what you already have. But Intercept X complements the current endpoint security by adding another number of features of layers in protection. And now let's have a look in this scenario which layers of protection will protect us from this first scenario which Tobias was just showing.
Okay, then let's switch our victim's perspective, and we go to the Sophos protected client. On the left, you see, okay, now Sophos Intercept X is installed. on the right side, we still stick with our attacker setup. We open up our emails and we are getting the same message, please customer install our tools, and we try to access the website. Okay, our phishing site is loading, and we also already see the first difference.
Right. Now this is the first protection layer. You see the web protection actually noticed that this website, amazonwebservice.de, is not an official Amazon website, but it's a malicious website put up by the hacker. So this protection layer, that's what the 50% of malware you can prevent from getting to the system at all, is in this case done by preventing the infection in the first place by blocking the website. Okay, now to make it easier for the attacker, I'm going to the Sophos endpoint and I'm disabling the web control. I can do this because the tamper protection is disabled on this system, so I can disable this policy for hours, and I'm just doing it for you. And now if we now try to get to the website, well, now we can. So this protection layer is disabled. Please go on, Tobias.
Yeah, to recreate the setup from before, we try now to download our easy executable.
And here you see there is a message from the Sophos endpoint that there's a detection of ML. And this is not the traditional antivirus, it's from our machine learning, from our deep learning engine. So even though we did not know this EXE before, because it's been freshly created by Tobias, it was blocked by our machine learning, our deep learning technology. Okay, so obviously this kind of attack is not successful with Sophos. Now try the more advanced with a MSI installer.
Sure, happy to. So let's download the installer again and recreate the steps from before. So already, like before, you're able to install the backdoor execute, the installer to execute it. We install them and wait for it to complete. So yes, we want to install it, which is nice. Yeah, this is a very, very nice feature from Shellter. So the functionality of the backdoor executable is not affected. So this means users won't get suspicious because the installer is really working. You get your tools set up and you don't get any notifications. So we're waiting till the install is complete. Yeah, finished. And fire up again our command prompt and try to execute the AWS command line interface like before. Whoop.
Okay, and now you see the next Sophos message. It says Code Cave, and Code Cave is a technology actually detect those kind of backdoored executables, of backdoored applications, because the traditional antivirus and even the machine learning did not detect this. Because this tool, which Tobias has been using, shellter, and there are also other tools, they use very advanced techniques in order to prevent detection from the traditional antivirus and even from modern machine learning, deep learning technologies. So we implemented a special technique to detect these backdoored, these code-caved executables. So you see, this kind of attack is not successful. There have been 3 layers of protection with Sophos. Let's have a look at this. What layers have been there in the current demo? So these were the technologies, those in orange, which protected in the demo just shown with a backdoored executable sent via an MSI installer. So the deep learning, the exploit prevention, and the anti-hacker technologies. The blue ones are the ones which were running in the background. I will show you more about this. Now let's go to a more advanced technique, Tobias.
Okay, so we have seen that traditional spearfishing with a backdoored and malicious executable is not working. So we tried to switch up to the next step and try a fileless infection. So how does this happen? You maybe have heard of the so-called bad USB attack, which is basically a lot of USB devices are not what they are not what they seem. This means a lot of USB sticks. They also can be very, very small computers, and they try to, or there are human interface devices and start typing on your notebook or on your computer. This means they are fully programmable keyboards. They are very, very fast and are able to execute commands really, really fast, so that no user can interact in between. What we usually do is we combine it with social engineering. So we will send to our potential victims gifts like this mouse. This mouse is a so-called bad USB device, and as soon as you plug it in, it will start typing and executing commands. To recreate this, I will go back to my victim machine, the victim 1 machine we have seen before. Close my stuff, fire up my reverse handler, and I just try to plug in the mouse here locally. Okay, and it's plugged in. As soon as it's connected to the system, it is starting typing. So what it is doing, it is starting a command prompt as administrator, answering the UAC, and then calling PowerShell with a malicious exe file. And we already, again, have our session in the attacker. Try to double check. Okay, yes, this is our desktop machine. And what we are now trying to do is we want to get some credentials from the system. So we try to escalate our privileges. Okay, we got system privileges, and then we try to access the SAM, where the Windows hashes are stored. So we use a post exploitation module called hashdump to get some Windows hashes. So okay, now it's listing users and keys. Let's give it a bit of time, and you see, okay, these are my Windows hashes. And yeah, what would be the next step? Now we have a hash, but from hash to password, sometimes if you use bad passwords, it's not a very wide way. So there are 3 online services. One of them is, for example, CrackStation. So you don't need a massive CPU or GPU cluster at your home. Just go online, put in your hash, and start such a free online service. Okay, crack caches, and you see, you get a very, very fast result, and obviously the administrator on this system has a very funny password. Interesting is, on the first side, this doesn't seem like a weak password, but it is obviously on a known password list, so you can very, very easily recover it from your hash. So a password, just keep it in mind, is also very, very important, not only endpoint protection. Okay, then again, try to switch up to the Sophos protected client. Also, we close our stuff from before to make it clean. We run our handler to wait for incoming connections, and we plug in again the mouse. We slowed it down for this demonstration so that you're able to follow the commands. In real world, we would speed it up. So now today we set the delays from seconds. Usually this would be milliseconds. So you won't have any time to react. Okay, moment. Try to replug in the mouse again. With virtual machines, it is sometimes tricky because when you click, it will lose the keyboard will lose focus and type in a different window. So okay, password prompt again, and PowerShell is executed. or not?
Or not, right. What you see now on the bottom is that PowerShell has obviously been blocked. The reason for this is that there is an application control in the Sophos endpoint which allows you to block application types like file sharing clients or remote control clients, but also software like PowerShell, like Flash Player, or like Java runtime environments. And in this case, PowerShell was blocked for the regular user, not for the administrator, but for the regular user, because PowerShell is in many cases used maliciously. And in this case, the application control was activated. Now we will deactivate the application control in order to give make the attacker come by this next wall, which they would have to climb to infect the Sophos infected system. But now we disabled application control, and see what's happening when we plug in this bad USB stick again.
Okay, so we prepared, as mentioned before, a snapshot, because sometimes it takes a couple of minutes when you change the settings. So you see now the application control is deactivated, and we are ready to go and try our next run. So on the right side, still our handler is waiting, and we plug in the mouse. But I think you can send a mouse, a USB stick. Also, e-cigarettes are very, very popular for spreading malware at the moment. Again, I'm very bad at remembering. Don't click in any other virtual machine window in between. So replug in the mouse, start the command prompt, bypass USC. I think this is a very, very cool feature that you're able to bypass the USC with this. And now we're able to execute PowerShell and load our prepared malicious file. And again, we see now incoming connections, which is very, very cool. Maybe we try to steal the passwords again, like we're trying to get a system. Yes, of course. And then, no, I don't want to.
Look in the window of Sophos, maybe there was a detection. So we got many exploit detection techniques, including those that we see if system privileges have been escalated and things like this. Maybe it's been done already. Could you retry?
Yeah, because they overlap the windows,
yeah.
So we didn't see it. So okay, one moment, I just fix it. Don't background the session. Yeah, so I need to set up the handler again. So to speed it up, we also cheated a little bit and deactivated some exploit mitigation features. So this is a state where the application control is set up, and the code caving we have seen before in the first example is also deactivated. So this allows us easier to show you another layer of protection. So we already deactivated 2 walls for this scenario. Okay, we set up our handler. And wait for incoming connections. So close it again and start it up. Yeah, as mentioned before, e-cigarettes are at the moment very, very popular because you plug them in very, very often and you buy them from some kind of suspicious sources.
Yeah, we've already seen that e-cigarettes, which directly come from China in many cases, that they are not just e-cigarettes, but also those bad USB devices and used to infect victims in this way. That's what we see in our labs.
Okay, yeah. So to make it easy for the attacker, we already deactivated the protection from PowerShell and also the code caving we have seen before. And again, if we want to try to access the hashes, we again, who's typing?
Not me.
Sorry about that.
Maybe the bad USB device is also connected to your SSH session.
Could be. Okay, run, and we just execute the payload again. And this time we will be very carefully at typing and don't background and destroy the session. Get system. Run post Windows. Again, this stopped. I know.
No, and this will also disable credential guard. We should have the snapshot with cred guard on. It's a very difficult setup because we need to put down some of the walls for the attacker and keep others of those functions of those walls against the attackers up. So that's typically we would not make it so easy for an attacker to deactivate functions, but to show you this layered protection approach that there are many layers against attacks. We prepared a few machines where just some of the Sophos features are active and not all of them, which is typically the way by default, which would be in your place. So we're just setting it up with now there is the application control deactivated, the code caving, the backdooring detection is disabled, and even some exploit techniques are disabled which detect the privilege escalation to system rights, which you just saw. So what we want to show here is actually to show you how passwords are protected in memory, because this is one of the things which attackers, especially with the GDPR coming, are trying to do. They're trying to steal passwords from memory or the SEM database, and we got special functions within Intercept X which detect and prevent this credential theft, which you just seen. Yeah? So you've seen the password theft of the non-protected system, and there are several functions which protect especially against this one. Okay, now we got this Sophos client where 3 or 4 layers are already disabled, and we just want to show you the last layer of protection, which is the protection of theft of the passwords from memory, or to be more precise, from the SEM database, because those hashed passwords, which Tobias just showed and cracked using the those rainbow tables, they are stored in a certain database in a Windows system. And this, by the way, is a current Windows 10 64-bit patch to the current state. So this is not an old system which has not been patched, it's a current thing.
Try to just cheat a little bit to speed it up and enter it manually. Because we have seen it started and then the typing happened.
Okay, so there the code caving is still active in this snapshot. So this is again the backdooring detection. There should be application control.
Okay, this is the code cave off as well, yeah. Yeah. So you see, it's not easy nowadays anymore to bypass next generation antivirus products. And the first part, on the victim 1, you've seen just the default Windows Defender, which is no problem. And when you're dealing with kind of more modern technologies, it is also, not so funny from an attacker's perspective, because, it's much more difficult to set up exploits and don't trigger all the alerts. Need to start it as administrator.
Yes. So the traditional antivirus, also the traditional Sophos antivirus, is not a state-of-the-art protection against modern threats. So you need advanced protection mechanisms like Intercept X. Okay, now let's see if this attack is successful when I think 3 layers are disabled on the Intercept X client already. Okay, now I see it's successfully executed, and there should be soon a shell coming in. There it is. This tool, which Tobias is using, is widely used also by attackers. That's what we also see in the wild in the Sophos labs. Together.
Yeah. Okay.
So now you see the protection of Sophos. You see this credential guard that a malicious behavior was detected. So the password protection was actually in effect. Sophos detected that there's someone trying to steal passwords in memory. So there are special protection functions in Sophos Intercept X against these kinds of protections. So let's sum this up from the demo perspective. The protection layers we've seen in this demo, the attempted password theft, those are first of all the app control, which prevented PowerShell from running. Then there was privilege escalation, code caving, exploit prevention, and then this credential theft protection. The blue ones are again running in the background, but you didn't see a message because of those. Yeah? So these were the protection layers for this demo. Please note that there was no file to be scanned. So any just machine learning solution is great for executables, but could not prevent this kind of attack. So you need those many layers of protection. Okay, now let's go to something which I hope not, but I think many of you are already familiar with from the type of attack.
Yeah, we also want to show you today some of the classics like the malicious Office documents. And with enabled macros, this still works in the real world because people are very curious. So we usually send out like salary sheets, this kind of top secret stuff. And yeah, somebody will click it and is also so curious and enables all the macros and disables all the warnings. So in our scenario, we stuck to the Amazon Web Services, and we generated a new price list. We sent to our already known customer, and we created a backdoor. We put a macro in it that downloads our own created ransomware called Checkbot, and we checkbot the users and try to get some ransom from them and make some real money. Okay. I think I also know from an attacker's perspective what happened before. The problem is when Sophos detects a threat, it will kick off a deep scan in the background, and then our malicious files are already listed as known, and we have a problem from an attacker side. So this means for me, if I misstep once, I have a problem because the red flags are on the field, and the malware protection engines are on the hunt. Okay, how do you prepare this kind of stuff? Easy, really entry-level stuff. So we created our Amazon Web Services price sheet. We took the original one. Usually you enter a message like, please activate your macros to get the latest prices. It is still very surprising for me how common Excel macros are. So you then enter your own macro. So we prepared one, which is downloading our stage 2 PowerShell exploit, and opens a new backdoor and downloads the checkbot. Okay, we embed it and we send it out. Let's go to switch it up to our victim's perspective. Let's starting with the victim 1. already known favorite victim, because it's the protection is default antivirus scanner, and we already got administrative passwords on it. So give my Mac some time. Kind of the wheel of death, this lollipop. Yeah, very interesting, because it should be a very powerful machine. But okay.
Maybe some notes from my side regarding the macro execution. The default setting in Microsoft Active Directory, if you set it up, is that macros are disabled for all users. But also the default in macro setup in Active Directory is that every user can press this button, enable macros. And that's why attackers are in many cases using this mechanism, because if you run a macro, actually the attacker can do anything that the user can do on the system. He can download software, he can execute software, he can put things together, so he can access confidential information. So anything that the user can do on the system can be done by the macro. Yeah? So this is a very popular way of attackers for collecting information or bringing malicious software, malware onto the system.
Okay. Sorry about that. I think I will do it the hard way and just restart VMware Fusion to make it a little bit faster.
Maybe some notes about what we see with in case of ransomware. We just released a study in January where we asked companies with 3- and 4-digit numbers, though medium-sized companies, about infections in 2017. And the very interesting fact was that about 54% of all companies we asked said they were infected with ransomware in 2017, and on the average twice. Yeah? So this is a very common threat. So even though those companies, they have firewalls, they have endpoint protection, they have email, they have web protection in place, even though they have this protection mechanisms in place, they were infected. So ransomware is still a very common threat. We had a peak of this in 2016 with Locky, but in 2017 with, for example, WannaCry, there was another very intensive year with regards to ransomware. So this attack, which Tobias is now showing, is how they are trying to get victims infected with ransomware. So that's again the machine which is not protected by Sophos, which is just protected by well, Windows Defender, which is not really a protection in the if you really think about it, because it's got some good detections with regards to antivirus. So the signatures of Windows Defenders are quite good, but this is not what security on the endpoint is about today. Yeah, so you need many layers of protection, as we already demonstrated, and we'll show you some more, which are needed for today's or against today's modern malware.
Okay, maybe
so
a little slower. Yeah.
VMware environment is having some problems.
We tested it over and over again, but this is the first time this kind of error rises. So quit it. It's always the demo gods are not with us today. Seems to be. Okay. Oh, here it is again. Great. So now it's reopening all the virtual machines again, and we're able to access our victims. Perfect. Yeah, we have seen we created the price lists, We also send them out by a phishing email. So you see, greetings from Amazon Web Services. You need to pay more money. Have a closer look at our price sheet. Yeah. Okay. Still, macros are disabled. Please activate them. I enable them now for us. And I see a window opening. This window is just usually very, very short. I just put it up longer. Usually you minimize it and hide it to the public so nobody will get suspicious. Now it's gone. You see, okay, a little bit troubling, but nothing to worry about. So we have now our actual prices. But in the background, very interesting, we did some stuff. I just want to start Explorer to show you. We downloaded our ransomware called Checkbot, and we kicked it off in the background. What Checkbot is now doing is, you already see files disappearing, and we just get the encrypted versions in a .coin. And we also get a classic notifications, all your files are encrypted. Please pay some money and you will get it back again. So still Windows Defender was not able to protect from this version. Now I'm trying to be very, very careful with my virtual machine setup and close this before. And we get back to our victim 2, the Sophos protected client. I'm restoring it and recreating the same version again. And we'll see how the system reacts to our new kind of attack.
Okay, now we're going to show several layers of protection here. So let's try to execute this. Let's try to run this. Yes. Just some introduction. There will be several layers of protection. What's happening with this macro, which Tobias has been preparing, is this macro is from within Excel. It's trying to run a script, a JavaScript, which then downloads a PowerShell, launches PowerShell to start a script which has been downloaded from a command and control server. So there are many embedded things happening within started from this Excel sheet. And the first mechanism, protection mechanism, which you will see, just press this enable content, and you see Excel has been terminated and there is a lockdown event prevented in Excel. Lockdown event means that within the context of Excel, what has been done by this macro is bad. It's considered bad because there is no business case for this. It's not forbidden. Yeah? So regularly a macro can do this. You saw it on the unprotected or just Windows Defender protected machine. It can do many things, but these things are considered in the context of Excel to be bad. So that's why we have a lockdown, a shell around applications like Word, like Excel, like browsers to prevent this kind of malicious behavior with our lockdown technology. Okay, now let's disable this lockdown technology by just removing the exploit mitigation, and let's try this again. Now this,
remember, you've seen the PowerShell before, but also on this machine, just to speed it up, we still disabled the application control again. Yeah. Usually this would be
right, but because normally when this macro launches, the next thing would happen is that PowerShell execution has been blocked. So the next layer of protection would have been there in place. We removed this. PowerShell was detected and blocked and also disabled the application control. So now we have the lockdown feature disabled, the PowerShell prevention feature disabled, and now the malware actually is being downloaded, is being constructed locally, and is being executed. Yeah? So now we let this software, this Checkbot is downloaded, it's executed in the background, and now it should try to encrypt the documents on the desktop in this folder. Let's try to see what happens on a Sophos protected system. We have a mechanism in the back that's monitoring if a process is trying to massively change files. So if we see a process trying to change lots of files within a certain time window. Yeah, you saw there's this .coin has been created, but also the original one. Oh, well, we see there are some things happening in the past. Let's see. It's also a bit depending on the timing of the application. So if this application is trying to modify many files within a short time frame, then we say our CryptoGuard technology is saying that this is very probably a bad behavior. Now let's just check if this behavior detection is on. It's called ransomware, okay? Detection, which is our CryptoGuard. And you see this malware is just trying to encrypt some files on the system. Now let's see what Sophos is doing. Now there it happened. You see, Sophos endpoint detected that there were some files modified. You see, this ransomware is not like the typical ransomware, which is encrypting very, very fast. This ransomware has been encrypting quite slowly, just one file every few seconds, but nevertheless our CryptoGuard has detected that there is something malicious happening, that there has been ransomware detected, and we did not only detect it, we also restored the original files, because in the background we're doing something like with something similar to the shadow copies, which we know from Windows operating system, which is doing copies in the background, and that's like our safety copies in the background, which were restored, so that there was not even a loss of the encrypted files, which were very slowly encrypted here. You see there's not the background. This executable has been detected and prevented. So what we just saw in this demo now is these layers of protection. So the application control, the anti-hacker technology, the anti-ransomware, and also the recovery of the encrypted files, so you don't even have to go to a backup. There's something else I'd like to show you. That is the root cause analysis. Could you just switch to Chrome, please? Yeah, because, yeah. So if we go to Sophos Central, which is the central management of Sophos endpoint, there you see in the central management that there has been credential theft prevented, that has been ransomware detected and prevented, and what we can also see here is the root cause analysis. The root cause analysis is like a flight data recorder running in the background, and if there is some credential theft like we just monitored here, then there's a way to analyze what has been happening. Like here, you can see this is the chain of things which happened. So the PowerShell wrote the malware exe. This was executed. It was injected into the Explorer exe. And here we noticed that some bad things were happening. We see which files were actually written. We see what was done. This was the credential theft which was detected. I can show you another one. Let's have a look at the root cause analysis of the CryptoGuard event, which we just saw. Let's have a look at this. And there you see, for example, the thing with the jackpot exe. Outlook wrote this XLS, this price list. Excel read this one. Then Excel started PowerShell, and PowerShell wrote jackpot exe. It was started, and the blue one means that we detected that jackpot exe is doing something malicious, like writing files. And here you see the .coin files. Those are the files which jackpot.exe was writing. And you also see what was that jackpot.exe was connecting back to the jackpot support command and control server in order to put down the information how to decrypt, how to extort money, how to decrypt. This is a root cause analysis which you get for every event that has been happening, and this is a very, very good way to analyze an attack afterwards and to show what has been happening, how had the malware been coming in, what has it done, has it spread to other systems, and this is one of the ways which gives you much more information than the pure protection functions. So all the protection functions are important, but nevertheless you need more functions for today's endpoint security, like those layers here. This was the root cause analysis, for example. So This was, I think, a very interesting demo from your side, Tobias. Thanks a lot for this, because you showed us how attackers today, how real attackers today are attacking enterprises, and I gave you the information what technologies and products can be used to counter those threats. And this side, there will be some webinars in English, Polish and Czech language. Here are the links. You will, of course, get those slides afterwards. So now let's switch over to the colleagues who have been answering questions in the background. We're a bit short of time, but maybe we have one or two questions for Tobias and me each.
So then I will start with a question for Michael. So one of the most questions I got is this protection only available for Windows operating systems or Windows client operating systems? So what about Mac and what about servers?
So this technology is also available for Mac. On Mac, you have mainly the encryption detection and prevention. The other anti-exploit techniques are, due to the operating system, they cannot be implemented in the same way, but the encryption detection and prevention is also available there, and of course the application control, the web control, and other control things. On Windows servers, we also do have the encryption detection and prevention, and in the next few months we will also get a product similar to, it will be probably called Intercept X for servers, which will give you also all the other protection functions which I showed in protection layers also on Windows server operating systems.
And one more question for Michael before I hand over to Stefan. So another question was, why wasn't the phishing email blocked by Sophos? So why don't we block something or completely block everything on the endpoint?
Actually, if it would have gone through the Sophos mail systems, it would have also been blocked, because the URL inside this phishing email would have already been blocked by email security, because we know that this link is malicious. Yeah? And if it had gotten through email systems connected to the Sophos sandbox, the sandstorm, then which also includes the machine learning, it would also have been blocked. The only thing which will probably not have been blocked is the backdoor MSI AWS EXE, because this is not detectable in typical scans from antivirus, from machine learning, or even in virtual environments. It's hard to detect this. This would probably have been the last thing for which we would have needed Intercept X.
Also,
Great,
from my perspective, maybe we also deactivated the web control to be able to download all the EXE and the MSI installer. Just remember it. The Amazon Web Services, our phishing domain was blocked, and we were not able to download the malicious files as long as we had the web control on. Yeah.
Okay, now I'll take over. Thank you both. A lot of people seem to be scared by our phishing campaign we demonstrated. Even some asked how we get to inject the original AWS client on the original site, the fake client on the original site. So Tobias, what do you think can you effectively do against such kind of sophisticated phishing attacks?
Yeah, there are multiple ways. So there is not only one solution to prevent from all threats, so you have to take multiple angles. So we've seen today a very good endpoint protection system is a first step from a technical perspective. Again, you can also take some measures on a mail server and do some advanced phishing detection, spam prevention on the mail server. But nowadays, still 90% of all attacks target the humans, the employees. So a very good training campaign, security awareness campaign, I wholeheartedly recommend to you. So we, for example, offer to our clients, we do phishing campaigns for training for them to make the people aware how modern attacks work. Don't type in your passwords, don't download stuff, how to handle them, and also communication is a very big step to get an environment working of people that show respect for errors, because errors will happen, and support each other of how to detect phishing mails. So there's no one solution. You have to take technical steps, but you also please don't forget the employee to train them.
One note from me, from Michael, Sophos also has a product called Phish Threat, where you can run phishing campaigns against your employees in order to check whether they would open the email or even click on the link, and you can get a reporting on this. This is a very good additional training, in addition to classroom awareness trainings done by companies like AlphaStrike Labs, and this is also something which can be done from Sophos Central, where you manage the endpoint. You can also run phishing campaigns.
All right, thank you very much. Unfortunately, we are out of time. Thank you, gentlemen, for the exciting webinar. Again, the webinar has been recorded and you all will receive the recording and the slides with the follow-up email tomorrow. What you will also receive, the registration links for our technical webinars that are taking place next week. Thank you again for joining us today. We hope you liked our webinar and we would be happy to welcome you in one of our upcoming webinars. The closest ones are the technical webinars next week. Thank you again and have a nice Wednesday. Goodbye.
Thank you for having us.
Thanks a lot. Bye-bye.